What if an AI could predict a patient turning critical before it's too late? In high pressure ICU environments, every second matters. Introducing Meridian Health Systems, a virtual AI powered diagnostic engine built on real ICU data like Mimic4 clinical database. It instantly classifies patient condition into 4 clinical risk level, and most importantly, it shows exactly why. Because in AI, the model you choose changes everything. Now let's step inside the system and see how it works in real time. Hello guys, welcome to my YouTube channel. In this video, I will be demonstrating my next project, which is Meridian Health System. So without wasting any time, let's directly execute the project and start the project demonstration. I will simply open command prompt in this folder by typing cmd here, and as you can see, the command prompt has opened. Now as usual, I will simply activate the virtual environment. So the command to activate a virtual environment is venv/scripts/activate, and as you can see, the virtual environment has activated here. Now let's simply type the command to execute this project. So the command is python app.py, because this app.py file is present inside this app folder. Now let's simply hit enter, and as you can see, it's loading models and the website is live, and we can access this application at this URL. So I will simply control click on this URL, and as you can see, the beautiful hospital-based Meridian system has opened in front of you. Now before we directly jump into the project demonstration, let me quickly explain what this system does. Meridian Health System is designed for a virtual hospital interface that transforms raw ICU patients' data into real-time clinical insights. In real scenarios, doctors deal with large volumes of complex data, which can delay critical decisions. This system simplifies that using AI. It takes 11 clinical parameters, including vital signs, lab values, and processes them through multiple machine learning models trained on real ICU datasets like Mimic4 clinical database, achieving around 96% accuracy on unseen data. After taking patient's detail, this system classifies the patient into 4 clear health states, starting from stable to very critical, making severity easy to understand. But the most important part is that it doesn't just predict, it explains, highlighting exactly which parameters are abnormal, so you exactly come to know why the prediction was made. Also, it allows you to compare different AI models and see how the model selection impact the result. So with that context, let's move into the system and see it in action. So I will simply click on this enter consultation room to test this project. This is the beautiful user interface, and here Dr. AI will provide you rapid stability diagnostics after you enter patient health details. So let's start. So first is engine configuration. Here I have provided 6 options from which you can choose any of them. So for now, let's select the default one, and here is the random patient chart button, which helps us to directly fetch sample values from the dataset. And after clicking this button, it will fetch sample record from the CSV file, which is present in the data folder, which is this testdata.csv. Now let's move to the application. For now, I will not click on this button and explain you each feature one by one, and then we can use this option of this button. So let's move ahead. The first is gender selection. So let's keep it to male, and here as you can see, for every feature I have tried to provide a basic example so that you can get an idea that what input should you add. So I will simply enter age, let's say 76. This is the basic patient information, which is gender and his age. Then moving ahead, here comes the vital signs. Enter heart rate, and it's giving that 60 to 100 is the normal. We can add heart rate accordingly. So let's add 98. After that, body temperature. The normal body temperature is 36.1 to 37. So let's keep it to 37 for now. Moving ahead, here are the few laboratory results that we should provide input. First is creatine, and the range of this healthy creatine is between 0.7 to 1.3. So let's keep it to 1. And next is the glucose part, and the normal blood sugar level is between 70 to 100. So I will simply make it to 98 for now. Next is the hemoglobin, and hemoglobin simply tells the protein present in the RBC, which is red blood cells, and the normal value is between 12 to 17.5. So I will add here 15 for test purpose. The next is platelet count, and the normal platelet count ranges from 150 to 450. So I will simply make it to 345. The next is potassium, and the normal range of potassium is 3.6 to 5.2. So I will simply add 4.5. Moving ahead, the next is the sodium, and the normal range for sodium is 135 to 145. So I will simply add 140. And last but not least, which is white blood cells, which are really important for our immunity. And the normal range is between 4.5 to 11. So I will keep it as 9.2. So as you can see, I have added all these 11 features, and now let's simply test this project by simply clicking on this submit to Dr. AI. And let's see what Dr. AI says about this patient. So as you can see, it's evaluating and the observation is normal. And the reason is that all vitals indicates are with clinical ranges, which simply says that all the parameters that we have provided are between the normal range, and due to this the patient health is normal. Logically thinking, this is correct also, because everywhere we add the value between the range that was provided to us. Now let's try the same with different model. So I will simply choose balanced random forest model and simply click on this road random patient chat button to see how features are imported from the test data. And as you can see, the features are changed to female, age is 58, heart rate is 90, temperature is 36.9, and here are the laboratory results starting from creating to white blood cells. Now let's test it. And as you can see, the health status of that patient, which is female, is poor, and the clinical observations are creatine is below normal, glucose is above expected, and hemoglobin is low. Now let's simply try to test the outputs from the test data itself. So I will simply go to the top. Now let's directly move to the test data.csv file that I created for this project and verify if the outputs are matching or not. So I will simply go to this project application, click on this data and open this test data file. So as you can see, here is a list of the 11 features that I have used in the project, and let's simply try to input data one by one and see the result. So for now I will select this first record, and this health status of that record is stable. So I will simply add all these details into our application to test the output. As you can see, the gender was male, age was 60, which you can verify it here. The heart rate is 113, temperature is 36.9, which is this. And in the similar way, I have added all the remaining features. You can verify it by pausing this video. So these are the laboratory results that I have taken from test data file. Now let's simply submit this detail to Dr. AI and see what Dr. AI says. And the result is normal, as you can see, and the expected output is also stable, which is correct. Now let's try the details of some other patient. So if we scroll down, we are getting this poor patient details. So I will simply select this patient, which is this, and once again, to save our time, I will simply add all these features and see the output. And as you can see, I have added all the details of that patient whose health is poor. So as you can see, the gender is female, age is 50, heart rate is 79, temperature is 36.9, and so on, that we just added of this record. And as you can see, the expected output is poor. Now let's simply test it. So I will once again click on the submit to Dr. AI button and let's see. And as you can see, the output is poor and the clinical observations are in front of you, which is creatine was high, glucose was high, hemoglobin is low, and white blood cells are too much. So in this way, you can test this application for a critical as well as very critical patient. Now I would like to take you to the most important part of this project. What will happen if we use less accurate model in this system? I have purposefully trained the less accurate model, which is of logistic regression, for demonstration purpose. So we will simply select that model and click on this button to load random values. And I will simply hit this submit to AI button. As you can see, the prediction result is not really very good, which is of only 48%. And this may classify patient health incorrectly. This is happening because logistic regression assumes a linear relationship between inputs, but in real medical data, patient conditions are influenced by complex, nonlinear interactions between multiple parameters. And in real healthcare system, this kind of inaccuracy can be dangerous because the critical patients can be classified as stable, leading to delayed treatments. This is exactly why model selection becomes an important part, especially in the sensitive domains like healthcare. Now this was entire system in action. Now let me quickly walk you through other sections of this application. So let's simply start from the main lobby part. As you can see, this is the main lobby part. This acts as a central entry point to the Meridian Health System, where user can securely access the platform and understand its core purpose, which is to monitor clinical health indicators and detect early signal of patient health using machine learning. From here, you can directly enter the consultation room by clicking on this button, and this section is already explored. Now, just below it, we will find diagnostic patient tier system. which is essential how the system categorizes the patient condition. The first level is stable, where all vitals are within the normal biological ranges, followed by poor, indicating mild anomalies that required scheduled medical attention. Next is critical, where there is significant deviation from normal parameters and immediate attention is needed. And finally, very critical, representing severe biological distress, where emergency or ICU intervention becomes necessary. This tier-based system helps us to simplify complex medical data into clear, actionable insights, making it easier to prioritize patient health status. And with that, let's move to the next section of this project, which is medical archive. So I will simply click on this medical archive section. Now next we have medical archives, which act as a medical records repository for this system. This section provides a direct view of all historical patients' data. At the top you can see the archive overview, which includes total number of active records, which is 100, and number of clinical parameters that have been tracked. Actually in this project there are 11 parameters tracked, but one is of the ID of that patient. That's why it's showing here 12. And all this helps to give a quick snapshot of data scale. Moving ahead, here is the parameter directory, which defines each feature used in the model, starting with vital signs like heart rates and temperature, followed by laboratory results such as glucose, creatinine, hemoglobin, white blood cells, and electrolytes, and finally the profile attributes like age and gender, which influence biological baselines. After that, here comes the distribution analytics section, where I have tried to provide you the insights of dataset that I have used to train the model. So let's explore them one by one. So first is the health status distribution across the dataset. So as you can see, the four main states are poor, stable, critical, and very critical. And as you can see, the dataset is evenly distributed. This was health status. Now let's move to the gender distribution. Gender distribution is also as good as 52 and 47%, which is good. Moving ahead, here is the health status across different age groups, starting from 0 to 18, 19 to 40, 41 to 60, 61 to 80, and 80 plus. And in every age groups, you can see the health status like poor, stable, critical, and very critical. Moving ahead, the next is the average heart rate analysis by health status. So as you can see, the average heart rate for critical status patient is 90, poor is 91, stable is 87, and very critical is 93. Now let's move ahead to see the recent chat samples. Here you can explore the actual sample records representing real patient entries with all clinical parameters along with their corresponding health status, giving us a practical view of dataset structure. Moving ahead, the next is statistical averages. This includes mean, standard deviation, and range value, which help us to understand the overall behavior and distribution of each parameter. This entire section ensures transparency and provides a strong data foundation behind AI system. And with that, let's move to the next section, which is R&D Lab of this project. So I will simply click on this R&D button. And as you can see, here we have Research and Development Laboratory, which serves as an internal portal for analyzing the performance of all machine learning models that are being trained for this application. This section is especially useful for understanding how different algorithms behave for same clinical dataset. Here you can see the different model engines integrated to system, starting from random forest, which combine multiple decision trees to produce high accurate and stable predictions, followed by balanced random forest, which is optimized to detect rare but critical cases. Next is LightGBM and XGBoost, which are advanced gradient boosting technique known for their speed and performance. Next is XGBoost, which improves prediction by learning from previous errors. And finally, the logistic regression, a simple baseline model used here to demonstrate limitations of basic approaches used in complex applications like medical scenarios. Moving ahead, here is the overall comparison of all the models that we have trained. So let's explore them. First is the model accuracy comparison. As you can see, the balanced random forest is giving us higher accuracy, followed by random forest, XGBoost, and so on. Next is the ROC curve of all models, and as you can see, the LightGBM is giving good curve, which is of 99%. And next is the F1 score of all models. As you can see, random forest, XGBoost, balanced random forest, and so on. For your information, I have used all these images from the Jupyter file on which I have trained the models. Moving ahead, the next is the precision comparison score of all models. And the next section comes, which is of individual model diagnostic. Here I have just tried to provide the accuracy results of all the models, which includes accuracy, precision, records, F1 score of individual models. So this is of random forest, next is of balanced random forest, after that LightGBM and XGBoost. Here I have only provided metrics performance of top 4 models. And finally, moving ahead, we have performance matrix, which provides a clear summary of each model analytics accuracy along with its saved file. As you can see, ensemble models like random forest, XGBoost, balanced random forest achieve around 96% accuracy, while simpler models like ADA-boost and especially logistic regression show significantly lower performance. Clearing highlights the importance of selecting right model for complex healthcare application. This section not only validates the system performance but also demonstrates how different machine learning approaches can lead to different outcomes, which is exactly what we explored earlier in the live prediction demo. And with that, let's move to the next section of this application, which is About section. So I will simply click on this About button, and here comes the About section. And in this About section, I have tried to provide a high-level understanding of vision and architecture behind the Meridian Health System and the core idea driving this project. Starting with AIM, this system is designed to bridge gap between the large-scale raw patient data into an immediate actionable clinical insight using intelligent machine learning workflows. The objective is to rapidly classify incoming patient vitals into 4 main stages while achieving high accuracy and reducing manual review time. And for the long-term vision is to build a universally accessible AI-driven healthcare layer that can assist medical profession in detecting patients' health before it becomes life-threatening. The next is the system architecture. From a technical perspective, the system leverages multiple ensemble machine learning models trained on clinical datasets like Mimic clinical dataset. This architecture processes various psychological parameters and mapped them against defined medical thresholds. By combining multiple models like decision trees and boosting algorithm, this system provides fast and reliable diagnostic options, helping to improve decision making in critical scenarios. And last but not the least, here comes the project creator section, where I have just added the dummy images of the creators with their dummy information. And with that, we have fully completed walkthrough of Meridian Health System, from data to diagnosis and from models to real-time predictions. Now let's move to the understanding folder structure of this project. So now I will simply open the root folder of this project, which is this. First is the app folder where the Flask application code is present. So let's go inside this app folder and see its folder structure. So first is static templates, which is the standard name that we use for Flask applications. So inside this static, we have CSS, images and JS. CSS include the CSS files, JS include the JavaScript files, and images includes the files and images that we have used in the user interface of Flask. Moving back to the app folder, the next is templates. It contains the multiple HTML files or the section which we explored few minutes back. And coming to this app.py file, this is the main entry point of this Flask application. Now let's simply move one step behind to see other folders. The next is data. Inside this folder, all the data is present on which the models were trained, the test data file which is this, the hospital data, the ICU details and everything you will find in this folder. Now let's move behind and go to this model folder where all these 6 models are present along with the features column.pkl file, which includes the list of features that we should provide to model. Now let's move one step behind to explore the next folder, which is notebook. In this folder, this is the Jupyter notebook where I imported the dataset, do basic EDA feature analysis and created a pipeline using which the models were trained and pickle files were generated in the models folder. Moving back, this is the virtual environment where the application is running, followed by the requirement.txt file, which includes a list of packages that we should install to execute this application. So this was the folder structure of this project. Now let's simply move to the main user interface of this application. And that brings us to the end of this project demonstration. I hope you got a clear idea of how Meridian Health System combines machine learning models with real-time clinical data to deliver fast and explainable diagnostic insights. If you found this project interesting or learned something new, make sure you hit like button and subscribe to my channel for more such AI and real-world projects. I regularly share complete implementations along with source code and setup guidance, so you can build this project on your own. Also, let me know your thoughts and suggestions in comment section below related to this project. I would love to hear feedback from you all. And if you want this entire project setup, just DM me on Instagram. So that's all for this video. Thanks for watching this video and I will see you in the next video with next AI project.